after your quiz, we are going to look at these 2.5 notes. Make sure that you did pick up the hard copy of these notes so that you can follow along with me. We're going to talk today about scatter plots and lines of regression. So just a couple of key words here. This bivariate data means data with two variables, and then we can graph that data using ordered pairs in a coordinate plane, and we call that a scatter plot, or you might hear dot plot. You're going to hear me mostly say scatter plot, okay? So if you look here, there are correlations that can occur within scatter plots or within two variables. So we can have a positive correlation, a negative correlation, or no correlation between them. And if it's a strong correlation here, the points of the scatter plot are closer to the graph of a line than the points representing a weak. So if there is a correlation, I'm going to scroll down here, then you will see, here are the examples here. This is a positive correlation. Notice that for this positive correlation, I can draw a line that's going uphill from left to right, so it has a positive slope. And notice that those dots are pretty close to that line, so that would be a pretty strong correlation because those dots are close. Here we have an example of negative correlation. The line of best fit, or the trend line, is going downhill from left to right. Again, that slope is negative, so we would call that negative correlation. And then lastly, in this one, you can see that there's really no pattern to draw a line through for it to make sense, so this would have no correlation with it. The last thing is just when you find a line that closely approximates a set of data, you're finding a line of fit. And an equation for this line is called a prediction equation. So when you're asked to predict something with this information, you can use your equation to do that. This also could be titled a trend line. So just so you know the different vocab that you might see, so you're aware. So you might want to put that down. Okay, so let's look at some examples of this. So if we move to this next page here. So we're showing here when working with a scatter plot, it's often valuable to attempt to create a line of fit. So we have a line of fit right here. Using the line of fit, we can create a prediction equation, which will allow us to make predictions. So for example, on this one, if you were supposed to make a prediction about what will happen at age like 80, let's say. And so you can look at this line to make your prediction. Or you can write your equation and then plug in information like a plug and chug to be able to do it. So let's look at this example that we're going to do. So the table below shows the approximate percent of students who sent applications to 2 colleges in various years since 1985. Make a scatter plot of the data and draw a line of fit. Describe the correlation. So we're going to take these points right here, ordered pairs. Time, remember, is my independent. X percent will be my dependent, which is my Y. So let's make sure that we label our axes. So my Y-axis is going to be percent, and my X-axis are my years, and this is really my years since 1985. And then I'm going to label my percent. I'm going to go by, let's go by fives. So 5, 10, 15. I guess we could spread that out a little bit more. It doesn't matter how you do it. I'm gonna spread that out some here. So 5, 10, 15, 20 is my highest, so I can stop there. And then my years, I have 0, and then 3, 6, 9, 12, 15. And then we're just going to graph those points. So the point 0, 20, 3, 18, 6, 15, 9, 15, 12, 14, and 15, 13. Okay? And so we're going to draw a line of fit for this. So you're going to want a ruler, and I'm going to, when you do this line of fit, you really want to pick 2 points on your line that look like the best. So I'm gonna do this point right here, and this point right here is where I'm gonna draw the line. So the goal is, when I draw this, if you notice, when you do your line, the goal is I have the same number of points above the line as I do below the line, as best that you can, okay? And so describing the correlation on this one, the very final part, this is a sloped line going downhill. So this would be negative correlation, okay? And we're going to use those 2 points. I'm going to just circle those so we remember what those 2 points are. Those are the 2 points that we're going to use in the next part of this. So part B, where they are asking us to use 2 ordered pairs to write that prediction equation. So those 2 ordered pairs that we had were this point right here, which was 0, 20, and then this point right here, which was 12, 14. Okay, so then I'm going to go ahead and erase all of this here. And then we're going to write an equation. So remember, first thing you need to do is find the slope. So I'm going to do 14 minus 20 over 12 minus 0. So that's negative 6 over 12, which reduces to negative 1/2. And then in this case, that, since that's a 0 for my x, that is my y-intercept, my b. So my equation, my prediction equation is y equals negative 1/2 x and then plus 20. And there's my prediction equation. If you didn't have a y-intercept as one of your points, which you won't always, then you would just plug in your m and then use one of these points to plug in your x and your y and solve for your b, like you did in your 2.3 notes. Okay, looking then at the next part of this question is predict the percent of students who will send applications to colleges in 2010. So again, you can use your picture, that's what I was talking to at the beginning, and make your prediction, or we came up with this equation, so let's use this equation. So I want to know in 2010, so time, remember, was my x, and that represents my years. X was my years since 1985, right? So I got to figure out 2010 would be 25 years since 1985. So I'm going to take that 25 and I'm going to plug it in for my x. So negative 1/2 times 25 and then plus 20. And my prediction of the percent of students will be 7.5% of students. So you're going to get a more accurate prediction if you use your equation versus just looking at your graph where you're looking at that line here. Let's say if this was our the line of best fit that we used, and really you're just guessing. So it's like, okay, year 2010 is somewhere over here, and then I'm just guessing where I think that line is going to be. This is going to be a little bit more accurate. Okay? The last part of this question is how accurate is this prediction? And really what that's asking is your line of fit a good line? And I would say in this case, yeah, like the points are fairly close to the line. And our line is in the middle of our data. And so that gives us a pretty accurate prediction. So again, when you're making your line of fit, make sure that when you draw your line, you need a ruler, and you're also going to pick 2 points from your data. Don't just draw a line through it. You do want to use 2 points. Okay? All right, so here's the next one. This says the table shows the approximate percent of drivers who wear seatbelts in various years since 1994, which shows the best line of fit for the data. So you're looking here at each one of these. Where does the line seem to be making the most sense in going through those points? And I hope that we're all seeing it's going to be C, that line there is the best line of fit. Now, the scatter plot shows the approximate percent of drivers who wear seatbelts in various years since 1994. What is a good prediction equation for this data? And they have given us the points that they want us to use. So again, the first thing we need to do is find that slope. So I'm subtracting my y's, 81 minus 71 over 12 minus 6. So that's going to give me 10 over 6, which reduces to 5 over 3. Okay, now in this case, since it's multiple choice, I can start eliminating. The slope of A is 3/5, B is negative 3/5, and C is negative 5 over 3. We know that this is our slope. Here's something else I want to point out to you. This last number in your line of fit is your y-intercept. That means if you're doing this accurately, your line of fit should be going through whatever number you have here as close as possible. It's not going to be perfect, but it should be close. And as you can see in this case, it definitely is. Okay? Answering the next question regarding this, using this equation, approximate the percent of drivers Y who wear seatbelts in various years X since 1994. Predict the percent of drivers who will be wearing seatbelts since 2010. So again, X represents the years since 1994. So 2010 is my years, so that's my X, and 2010 would be 16 years since 1994. So I'm going to take this equation right here, and I'm going to take 16 and I'm going to plug that in for X. So 5/3 times 16 plus 61, I'm going to get out 87%. Okay? All right, here's the last one. We're going to do kind of this whole thing together. It says the table shows the mean selling price of new privately owned single-family homes for 6 consecutive years. So here's that table. We're going to make a scatter plot and a line of fit and describe the correlation. Okay, so again, we need to label our axes. So I'm going to, we know that the x-axis is our years. I'm going to put this off to the side so I have room for my numbers. And then this would be my price. And this price represents thousands. Okay? And I'm going to just go every like 3 and put a number here. So there's a 1, 2, 3, 4, 5. And then I'm going to go like start at 150 here. Let's see. And then I'll go by 30s. 180, 210, 240, and then 270. Okay, so let's plot these points. So we have the 0.0 and then 154.5, 1 and 166.4, 2, 181.9, 3, 207, 4, 228, and 5, 273.5. Okay? So we are going to draw the line of best fit. So you're grabbing your ruler, you're finding 2 points that you think will create the best line of fit. I'm going to use this point right here, just so everybody can see what I'm using, and this point here. to draw my line of best fit. Again, the goal is to try and have the same number of points below it and above it if you can. Okay, so there's my scatter plot, there's my line of fit. We want to describe that correlation, and this is a positive correlation. Okay, and then for B, we want to write a prediction equation. So I'm going to do that down here. So let's label the points we used. We used 1 and 166.4, and then 3, 207. Okay, so first thing we need to do is find our slope. So you're going to subtract your y's over your x's. You're going to get 40.6 over 2, which reduces to 20.3. So there's my slope. And now I'm going to find my b. So I'm going to take this point right here, and I'm going to plug it into that y equals mx plus b form. So 166.4 is my y, m is 20.3, my x is 1 plus b, and when you solve that, you should get b to be 146.1. So my prediction equation is y equals 20.3x plus 146.1. That's not a very good one. Plus 146.1. And again, I want to show you just to help double check. My y-intercept when I solved was 146.1. My line should look like it's crossing around there, and it's pretty close. So it looks like we did that accurately. Okay. C says predict the selling price of a new home for year 8. Year 8. So we're going to take this 8 and we're going to plug it in to x. Okay. So that's 20.3 times 8 plus 146.1. And you get out 308.5. Now, here's what I want to remind you of. Remember that the y that you're getting represents the price in thousands. So that actually is 308,000. So we want to write our final answer to reflect that, 308,050 cents. Okay? So there's my answer for C. And then lastly, D, how accurate does your prediction appear to be? Let's do this down here. And I would say pretty accurate because the line is in the middle of our data, which is the goal. Always trying to get it in the middle of your data. Okay? All right, so the very last thing that I want to bring to your attention is just this R value. So let's erase all of this here. So you can use technology to find a line of best fit. We're going to continue working by hand to do this. But it is important you understand this correlation coefficient, which is R, okay? And that correlation can tell you, this R can tell you something about it, whether it's positive, negative, or no correlation. So number one, your R can be any value from -1 to 1. So it's going to be in that range, okay? When R is close to -1, it's going to have a negative correlation. So it'll have a negative sloping line. When R is 0 or like really close to 0, there's going to be no correlation. No line could be drawn. And then lastly, when R is close to +1, it's going to have a positive correlation with a positive sloping line. Okay, so on this next question here, it says if a data set has a correlation coefficient of R equals -0.712, what does this tell us about the data? So just knowing the R can tell you something about that data. That is close to -1, so this would tell us that the data has negative correlation, a negative correlation. Okay, that is going to conclude your notes. There is your homework assignment. I have graph paper that you can use if you need it for your scatter plots. And that will be it. So if you have any questions, let me know.